Hi everyone, welcome to the Math 6 Unit 3 review, where today we'll be talking about unit rates and percentages. I've got about 13 problems today that we'll go over together here on this tutorial video. That should help you get ready for the Unit 3 test. Alright, without further ado, let's get started. Number 1 says a large bucket of water holds 5 gallons of water, which is about the same as 19 liters of water. Right, so we're kind of starting off with a conversion problem here. A small bucket holds 2 gallons of water. About how many liters is that? All right, you'll probably hear me say this a lot in this review, and you probably heard me say it in Unit 3 here, but something that's really helpful this unit is a t-table. Okay, so the two things I'm talking about for this t-table are gallons. So I'm going to abbreviate that GAL, and liters. Okay, I know this large bucket can hold 5 gallons of water, which it tells me is the same thing as 19 liters. And what I'm trying to find, it says, is a small bucket holds 2 gallons. How many liters is that? Okay, so just using my t-table here, I'm trying to figure out if I can hold 2 gallons in a small bucket. How many liters is that? So I'm trying to find this answer right here. Okay. Well, I know going from 5 to 2 can be a little bit tricky, but I know I can pretty easily go from 5 gallons to 1 gallon by dividing by 5. Okay, so I need to do the same to my liters. Divide by 5. Okay, 19 divided by 5. 5 goes into 19 nope. Not quite 4 times, because 4 times 5 would be 20, so it only goes in 3 whole times. And 5 times 3 would be 15. Okay, and how many do we have left over? We have 4/5 left over, so 3 and 4/5. If I wanted to make 4/5 into tenths, times 2 would be 8/10. So that'd be the same thing as 0.8. So I could say 3.8 liters in 1 gallon. And now, pretty easily to go from 1 gallon to 2 gallons, I'm just doubling. So all I need to do is double 3.8. So I need to times it by 2. When I do that, 3.8 times 2 would give me 7.6. So my answer, 7.6 liters of water in that small bucket. Number 2. Says bottles of sparkling water usually cost $1.69 each. This week they're on sale for 4 bottles for $5. You see that right here, 4 for 5. You bought 1 last week and 1 this week. Did you pay more or less for the bottle this week? And how much more or less did you pay? Okay, so let's compare last week, what we paid, to this week. Okay. Last week it tells me that it was $1.69 per, so $1.69 per bottle. So that's per bottle. And this week it tells me that I can get 4 bottles for $5. All right. So I got this comparison again. I'm going to make a t-table. $5, and I got 4 bottles with that. What I'm going to try to do is find out how much money is it for 1 bottle, because I know the price over here for 1. So how do I go from 4 to 1? Well, I just divide by 4. So same thing over here. 5 divided by 4. How many times does 4 go into 5? 1 whole time. And then there is 5 divided by 4. 1 whole time. 1 times 4 is 4. I subtract, I'll get 1. So 1 whole, 1/4 left over, and 1/4 I know is the same as 1 out of 4 quarters, which is 25 cents. Okay, So this week, again, they're on sale. It's $1.25 for one. Okay. So did I pay more or less for the bottle this week? I paid less for the bottle this week because it's only $1.25 per bottle. And then it says by how much more or less? Okay, well, if last week was $1.69 and this week was $1.25, I just need to subtract these two. 9 minus 5 is 4. 6 minus 2 is 4. And 1 minus 1 is 0. So it looks like 44 cents less I paid this week. Moving on to number 3. It says 2 pounds of grapes cost $6. Complete the table showing the price of different amounts of grapes at this rate. Okay. So here's my 2 pounds costing $6. This first one says, okay, I'm going from $6 to $1. So I'm dividing this by 6. Okay, same thing here, divide by 6. 2 divided by 6 would be the same as 1 over 3. Just simplifying that. So a third. If you wanted to, you could have put that decimal, which is 0.33 repeating. Same thing as 1/3. And that tells me for every $1 that I have, I could get a 1/3 pound of grapes. Okay? Or I also have this situation where I have 2 pounds and I'm going to 1 pound. So I'm taking half that amount. So again, to go from my original amount to my blank amount, I'd have to take half that. Well, half of 6 is 3. Okay? So number 2 says explain the meaning of each numbers you found. Okay, well, the first one that I found, 1/3, that represents, that represents the price of a 1/3 pound of grapes is $1. Okay, for $1 I spend, I can get a 1/3 pound of grapes. The second number that I found means 1 pound of grapes costs $3. Okay, so those are what those two represent in that table. Continuing on, number 4, a cheetah can run at its top speed for about 25 seconds. Complete the table to represent a cheetah running at a constant speed. Complete or show your reasoning. Okay, so it tells me that if this cheetah runs for 4 seconds, it goes a total of 120 meters. So to find speed, it says find meters per second. All right, so I want to find how far I can go in 1 second. Okay, so if it's 4, so if I have seconds and I have meters, and it's 4 seconds is 120 meters. What's my speed? Well, again, it's how many meters per 1 second. Okay, so how do I go from 4 to 1? Well, I just divide by 4. So if I divide by 4 here, well, 12 divided by 4 is 3, and add that 0. So that's 30 meters per second. Wow, that's really cooking. So it also tells us here that it's a constant speed. So that means that my speed is staying the same. So you can kind of cheat here and say, okay, well, if it's 30 meters per second, it's constant, it's staying the same the whole way because it's a constant speed, right? So here it says, okay, if that cheetah ran for 25 seconds, how far did they go? Well, if it's 30 meters per 1 second, and I'm going 25 seconds, all I'd have to do is take 25 times 30. Well, 25 times 3 would give me 75, and then add that 0, so 750 meters. That cheetah can go in 25 seconds. And then working backwards for this one, if the cheetah went 270 meters, and it's going 30 meters per second, how many seconds did it run? Well, okay, now I just have to work backwards and I have to divide. So 270 divided by 30, same thing as 27 divided by 3. Well, that would give me 9 seconds. And if you wanted to double check that, you could. You could say, okay, 9 seconds to go from 1 second to 9, that's times 9. So what's 30 times 9? Well, that'd give me 270. So that's how all three of those tables, or all three of those columns in that table kind of work together. Moving on, number 5 tells us that a penguin walks 10 feet in 6 seconds. At this speed, how far does the penguin walk in 45 seconds? Explain or show. And how long does it take the penguin to walk 45 feet? Explain or show. Okay, so again, going back to the old trusty T-table, I would be using these a lot on my test if I were you. They're so helpful. And I'm talking about feet and seconds. And it tells me this penguin can go 10 feet in 6 seconds. Again, the penguin speed is pretty slow. How far, it asks, does the penguin walk in 45 seconds? Okay, well, kind of something easy for me to think about is how can I get from 6 to 45? Well, I don't think there's a whole number I can multiply by right away, but I know I could go smaller right away. I know I could have this to 3. And then I know 3 can go to 45 pretty easily by multiplying it by 15. So here I divide it by 2. So 10 divided by 2 would give me 5 feet every 3 seconds. That's the same as 10 feet every 6. And then if I wanted to get to 45, well, like I said, 15, 30, 45. 15 times 3 is 45. So over here, I also have to multiply by 15. And 5 times 15 would give me 75 feet in 45 seconds. And number 2, how long does it take the penguin to walk 45 feet? Okay, so now this changes to 45 because it belongs in the feet category. Well, that's not too tricky. I already found out 5 feet in 3 seconds. So how could I go from 5 to 45? That's not too bad. That's just times 9. So to go from 3 seconds to this blank times 9, 3 times 9 gives me 27. So it would take 27 seconds to walk 45 feet. Okay. Number 6 says a restaurant sells 10 tacos for $8.49 or 6 of the same kind taco for $5.40. Which is the better deal, and how do you know? Okay, we did a whole day where we looked at better deals, comparing a bunch of foods and clothing items and stuff like that in our walkabout in class. Easiest way, once again, surprise, surprise, T-table. Dollars and tacos, and dollars and tacos over here for B. I'm just comparing these two. The first one compared to the second one. So 10 tacos for $8.49 or 6 tacos for $5.40. Easiest way for me here is to see, okay, how much for 1 taco? Okay, to go from 10 to 1, I just divide by 10. Over here, dividing by 10. Remember, mental math trick, move your decimal 1 to the left. So that would be 0.8, and I'm going to round this up 5. So about 85 cents for 1 taco here. And then over here, same idea. I want to get to price per 1 taco. So I'm going to divide this by 6. And again, you can just punch this into your calculator if you want. 5.40 divided by 6 would give me 0.9 or 0.90 for 1 taco. Which one is the better deal? Letter A is the better deal. How do you know? Well, it's cheaper. It's only 84 or 85 cents per 1 taco, where the second option is 90 cents per taco. Moving on to number 7. It says fill in the blank. The value of 8 dimes is blank percent of the value of $1. Okay, so if I have 8 dimes, I know 8 dimes is let's see, that'd be 80 cents, right? So 8 dimes is 80 cents. And in a dollar, there are 100 cents. Okay, well, luckily for us, remember, percents are out of 100. So it looks like if I had 80 out of 100 cents, that is 80 out of 100%. So 80% of the value of a dollar. Then the number 2 says, name a combination of coins that is 130% of the value of a dollar. So again, my value is 100 cents of a dollar. Then what I'm looking for is what makes $1.30 or 130 cents, which is the equivalent of $1.30. Okay, so you could say something like, oh, maybe you said a dollar coin. If you've ever seen those cool gold dollar coins, and that'd be a dollar, and then 3 dimes. All right, that'd be $1.30. Maybe you said something like 5 quarters. We know 4 quarters is $1, 1 more is $1.25, and a nickel. That would make $1.30. Some other ones, maybe you said something simple like 13 dimes. 13 times 10 is 130. I would argue that maybe this isn't a combination of coins, but maybe you said that it's just more than one coin, so that would work. But lots of different answers you could probably come up with there for the second part. Number 8 gives you a double number line, and it says a large bottle of juice contains 500 milliliters of juice. Okay, so all of it, the entire thing, is 500 milliliters. So I'm going to match that up with the 100%. So 500 milliliters. A medium bottle contains 70% as much as the large bottle. And so if I have a scale from 0 to 100%, it looks like on my percents I'm going by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yep. And remember, one of the easiest ways to break a percent down is to go from 100% to 10%, it's just divided by 10, right? 100 divided by 10 is 10. So what is 50 divided by 10? Well, 500 divided by 10 is 50. So 50 milliliters is the same as 10%. And again, I divided by 10 to find 10%. That's a really good mental math rule to be able to use, not only on this assignment, on this unit, but also in real life. It can really help you quickly figure out tips for like when you go to eat and those types of things. So if I know 10% is 50, well, to go from 10% to 70%, that's just 7 times as big. So 50 times 7 would give me, 5 times 7 is 35, and add a 0, that would give me 350 milliliters for that medium bottle. Okay. Now this is one way to do it. You could have also made a tea table. Surprise, surprise. Okay, you could have said our juice in milliliters and our percent. So 500 mils is 100%. Right? You could have said divide by 10, 50 mils is 10%, and then you could have multiplied by 7, right, to get to 70%. Same idea, using a tea table. Let's move on. Number 9 says, complete the statement with a situation and a unit of your choice, and then answer the question and draw a diagram. Okay? It says, a small blank holds 75% as much as a large blank. Okay, maybe you said something like, a small scoop holds 75% as much as a large scoop, or maybe you said something like container. Okay? Anything here that holds something, right, will work. It said if the small holds 36 units units, how much does the large hold? Okay, so I know that the small is 75% as much as the large. Okay, so whenever I'm dealing with 75%, I like to think of breaking it into 25% chunks. So if this is my whole, I would break it down half and half, and then break each one of those halves again, so that each one of these represents 25%, 25%, 25%, 25%. And I know that 3 of those together, so 1, 2, 3 of them, represents that 75% as much. Okay, so if I'm talking about a container that holds 36 units, that's the whole entire small thing. So that 36 needs to be broken up into this region, into these 3 regions. So if I did break that up, each one would hold 12 units, whatever unit we're talking about, right? So then I have 12 plus 12 is 24, plus another 12 is 36. Another size chunk to make that 100% would give me a total of 48 units for the large one. Okay, so I just added another same size there. Number 2, there's my diagram. Okay, so the large one would hold 48, the small one holds 36, in that ratio and that percentage. Okay. Moving on to number 10. It says, answer each question and explain your reasoning. How long is 50% of 60 minutes? Again, remember 50% is half. So half of 60 minutes is 30 minutes. It says, how long is 10% of 60 minutes? Now remember, 10%, that rule that we just talked about, you got to move your decimal 1 to the left. Okay, that's that mental math rule. So 10% of 60, move it 1 to the left, is equal to 6 minutes. Pretty easy. The other thing you could do is you could divide by 10. Those are the same thing, moving your decimal 1 to the left or dividing by 10 to come up with 6 minutes. And then the last one, how long is 75% of 60 minutes? So again, might be helpful to make that diagram. Okay, I'm going to split it into quarters, and then I'm looking for 3/4 worth. It's looking for 75% of 60. So if this whole thing was 60 minutes, how much would each chunk be worth? Well, it would be 15. 15 plus 15 is 30, plus 15 is 45, plus 15 is 60. So the whole thing is worth 60, and this says, what about 75% of it? So in other words, 3 out of the 4, 15, 15, and 15 would give me 45 minutes. Okay? All right, moving on. Number 11 says it takes Jada 20 minutes to walk to school. It takes Andre 80% as long to walk to school. How long does it take Andre to walk to school? Okay, again, it's kind of your choice here. Do you want to use a t-table, or do you want to use a diagram? It's both work really well, and I'll show you both just so you have a good understanding. Again, Jada's time it takes is 20 minutes. So, and I know Andre is 80% as long. So 80%, I know, is the same thing as 8 out of 10. Or if I simplify that, it's 4 out of 5. So if I broke this down into 5 chunks, so 1, 2, 3, 4, 5, I know that 80% is 4 out of those 5. Right? So if I did this, 4 out of those 5 is 80%. Well, if I broke down 20 into 1, 2, 3, 4, 5 different chunks, each chunk is worth 4. 4, 8, 12, 16, 20. And those are in minutes. And if I am looking for 80% of that, well, 4 times 4 would give me 16 minutes. Is 80% of 20. Okay. I could show you that over here in a t-table if I had time and I had percent. We know that 20 minutes was the whole thing, so 20 minutes was 100%. And I'm trying to figure out what 80% is. Well, just like before, I could find 10% of it by dividing by 10. So 20 divided by 10 is 2. And then 10 to 80, I'm just multiplying by 8. So 2 times 8 is 16. So I got the same answer as what I did using my model. Number 12 wants us to order these from the least to the greatest and then show how we got there. Okay. If you remember, this is a really good time to use your calculator too. One way that we talked about it is by making our percent into a decimal. Okay, so percent to decimal. We just move our decimal 2 spots to the left. Okay, so here 65% is the same thing as 0.65. Of, in math, remember, means times 80. Okay, so that's just a simple plug and chug into your calculator. 0.65 times 80 would give you 52. Okay. Here, 82%, 0.82 of times and 50. 82% of 50, punch that in, gives you 41. And in the last one, 170%, so 1, 2 would be 1.7 of the math is times 30. Multiply 1.7 times 30, you come up with 51. Okay. Now again, remember, this is just one way to do it, is using a calculator. But we could have also broke down 65% into 60% plus 5. And we could have said, okay, 60% is the same thing as 10% and 6 of those. And 5% is just half of 10%. Okay, so you could have easily done this mental math too. That wouldn't have been all that tricky to figure out. Okay, so ordering these from least to greatest, this one is the least. This one is the greatest. And then this one is the one that's in the middle. Okay. Finishing with number 13. A jet plane can carry up to 200,000 liters of fuel. It used 130,000 during a flight. What percentage of the fuel capacity did it use? Remember, of is a good way to remember. That's the whole. Is over of. Remember that. Is telling you part. Of is telling you whole. So of the fuel capacity, well, I know that it can hold 200,000 liters. That's my whole. And how much did it use? 130,000. So when I take and find this percentage, again, remember, it's just part divided by whole. So it's just 130,000 divided by 200,000. When I plug that in, I come up with, well, actually, I could just do this in my head. Right, all my zeros match up. It gives me 13 over 20. Which simplifies to 65%. They give you 0.65, but remember to make a decimal, move it 2 to the right. Okay, that wraps up the review here. Please let me know if you had any questions on any, and good luck to you on your upcoming test.